All right, hi guys. Today we are looking at 9.3. We're going into our next topic for our statistics unit. So today our focus is standard deviation. It's another way that we measure out the spread of a data set. So you will definitely want your graphing calculator today, or you can get the extension on your Chromebook if you don't have your graphing calculator with you. So let's look at this paragraph at the top here. It says, recently we reviewed several measurements of data sets, including range, which is the difference between the greatest and least value. Range is a measurement of the spread of the data, but sometimes it doesn't give us the most accurate picture. So we can look at how spread out the data is from range. So let's try that with this first example. It says find the range of the data set. Here's our data. And then we're wondering if that provides a good representation of the spread of the data. Okay, so let's do our range, max minus minimum, 15, minus the minimum of 1 equals a range of 14. Now, we're wondering, is this a good representation of the spread? Well, if we look at this data, it doesn't look like very many of our pieces of data are actually close to our range, 14. There's only one. So if I were answering this question, I might actually say no. It doesn't seem to be a good measure because most of the data, looks like most of the data is actually between 1 to 5. There aren't very many data points even close to our range. Okay, so we need another way to measure the spread of our data. So that's where standard deviation comes into play. It says the standard deviation, here's our symbol for it. That's a sigma. It's a lowercase Greek letter sigma. If I draw it by hand, it kind of looks like a circle with a flat top like that. The standard deviation of a data set is the measure of how close the data points are to the mean. Okay, so we're looking at the mean and saying, okay, well, on average, the data sets are a certain distance away from the mean. In this class, we only calculate it using our calculator. If you take more stats classes, you'll learn how to calculate it by hand. So we're going to practice using our calculator to figure out the standard deviation. So we have our steps here. And then we're going to actually use the same data set. So I rewrote it for you guys. And we're going to calculate the standard deviation. So let's follow the steps in our list. It says press the stat key. So here's stat on my calculator. And then we're going to press enter so we edit again. So we're trying to enter our list like we've been doing this whole unit. I have data from a previous lesson in here, so I want to clear it out. That's step 3. I'm going to go all the way to the top, highlight L1, and click clear. Click enter. And now I need to enter this data in. So I have 3, 5, 1, 5, 1, 1, 2, 3, and then 15. And then to actually find the standard deviation, I'm going to click stat again. I want to calculate, so I'll scroll over. And this time we want number 1, called 1 var stats. We've done this operation before when we were making box plots, so it's the same place. So we're going to click enter on number 1. And now, depending on your calculator, you might see other options here. Just keep clicking enter until the information pops up. So when we were doing box plots, we had to scroll down for these numbers, our 5-number summary. But for standard deviation, I'm actually looking at the top, and you can see on the notes, this is the symbol we're looking for on the calculator. Okay, it's a sigma with the x, meaning the standard deviation of your data. So that's right here. Okay, you have to be careful because there's a number right above it, this SX. We don't want that one. We want the sigma x. So if I want to write the standard deviation, I'm just going to write our symbol for standard deviation, so I don't have to write the whole word, equals, and then 4 point, we'll round to the 2 digits, so 4.16. Okay, that's it. Calculated my standard deviation. So not only am I going to calculate it, but I want to interpret it. What does that mean? So when we interpret standard deviation, we use this kind of sentence template every time, and we'll fill in the blanks here. So on average, a data point varies from the mean, so I'm going to type here, by 4.16 for this data, right? So it'll always be varying from the mean, so this word will always be mean, but the number you type here will change depending on the standard deviation, right? So now let's think, does this standard deviation seem like a good representation in comparison to like the range we calculated before? Well, 4.16, that looks a lot closer to most of these numbers. So I would say yes, it is a good representation because most of the data is around 1 to 5, right? It's somewhere near that standard deviation. It's not like our range we calculated earlier that was so far away from most of the data. Okay. Let's look a little bit closer at standard deviation and how it might impact a data set a little bit. So here we have some distribution curves, kind of like when we were naming those shapes before, but in this case we're just looking at how the standard deviation affects the shape. Okay, so you have 3 pictures here. They all have a mean of 3, but notice their standard deviations are all different. Okay, so take a moment. I want you to see if you can kind of figure out, well, how is the standard deviation related to what the picture looks like? Okay, so when I looked at these, to me it looks like they're... Okay, so here's kind of what I was thinking when I looked at these graphs. I noticed that the smaller standard deviations, those had a skinnier curve here, and a larger standard deviation was a little bit flatter, kind of a wider curve. And if we think about what we talked about before, that makes sense because if it's a smaller standard deviation, that means the data is a little bit closer to the mean. Okay, we'll look at these types of curves more, but the mean is going to be the middle of these normal curves. So the data of this one is a lot closer to the mean versus this one's more spread out. All right, so one more example together here, our last example together. So it says Jordan scores a 53 on his math test. The class average is 57, so that's our mean, and the standard deviation is 2. How many standard deviations below the mean did Jordan score? So this number here is his actual score. This is our mean, and this is our standard deviation. I don't know if I've mentioned this yet. This symbol here is a symbol for mean, and you can actually get that from your calculator. See the very top number when we do 1-bar stats? That's the mean. So if you ever wanted to calculate mean, you could use your list and do 1-bar stats to get the mean here. Okay, so I'm wondering how many standard deviations he was below. So if this was the average, if I take away, let's say I take away 1 standard deviation, that means I'm going to subtract 2. So this is subtracting 1 standard deviation. I only get to 55. Okay, well he scored 53. So let's see what happens if I do minus 2 standard deviations. Here's 1 standard deviation, here's the second one. Well, that equals 53, and that's his score. So that means I can say that he scored 2 standard deviations, I'm going to abbreviate here, below the mean. Okay. All right, so the last one, I want you guys to try it. You're going to calculate a couple standard deviations, and then you're going to compare those. All right, here is what I got when I calculated the standard deviation for each golfer. So golfer A, 4.63, and then my interpretation of that using that sentence from before. Golfer A's score varies from the mean by 4.63 points. Golfer B, 2.53. So golfer B's score varies from the mean by 2.53 points. So when we compare them, what can we conclude? Well, looking at the two standard deviations, it doesn't really tell us who's an actual better golfer because standard deviation is telling you how much they vary from the mean. So all it really tells us is that golfer B is more consistent, meaning because his standard deviation is smaller, his score is usually closer to his average. So he's more often scoring the same. He could be getting really bad scores every time, but he's more often scoring closer to his average score.